Hey everyone, welcome back to the channel. I hope you guys are doing all well. So we will see today's daily challenge on Leetcode and we will try to solve it together. So we have this problem, minimum swaps to arrange a binary grid. Given an n cross n binary grid, in one step, what you can do, you can choose two adjacent rows of the grid and swap them. A grid is said to be valid if all the cells above the main diagonal are zeros. Return the minimum number of steps needed to make the grid valid, or -1 if the grid cannot be made valid. Okay. And the main diagonal of a grid is the diagonal that starts at 1, 1 and ends at n, n. I hope you know this. And about this main diagonal. Okay. And what we need to do essentially is as shown in this example. So let's say we are given this grid 0 0 1 1 1 0 and 1 0 0. You see that in this top upper triangular this matrix. Okay, we have this one over here, but we want all of them to be zeros. So what we can do, first we swap the first and second rows. Okay, and then we swap the second and third rows, and then we swap the first and second rows again. In this way we get this all the upper triangular matrix to be consisting of zeros. And how that is becoming possible, you see at the first there was a row at the end. Okay, 1 0 0, this row 1 0 0, this row is made to be at the top. Okay, this row is made at the top, and this row is kept as it is 1 1 0 in the final configuration, and 1 0 0 1 is made to the bottom. That is why you see the top right matrix is nothing but all zeros. Okay, and that is our answer, and we need to sprint the number of steps required to reach this configuration. Okay, and if it is at all possible, you see in this example, no matter how many swaps you do, you cannot make this upper triangular matrix to be consisting of all zeros. Okay, some one will be there. Okay, so if you see the second and third row consists of all the ones. Okay, so no matter what which one you swap with which one, it will always be consisting of all cannot ever consist of all zeros. Okay, and I hope you already understood that in this example 3, it is already the answer is there, so you need 0 steps to reach here. So that's what you will answer. Okay, so and the constant is of 200 only, so you can do an n square n cube whatever. And yeah, and grid of ij is must be 0 or 1. So let's see the solution. I hope you will try it on your own first and then continue watching the video. So yeah, assuming you have tried this problem on your own, let's see what we need to configure. So you will be given an n cross n grid, and you need to make the upper triangle completely zeros. Okay, all zeros. Upper triangular matrix should have all the elements to be zero. So what if you, let's say n equals to 5, what do you want? What do you want? You want the first row to be consisting of 4 zeros. So you see, you have this matrix, let's say, and let's say it is 5 and 5. So you want 4 zeros to be present, and this element can be anything. Okay, and again for the next row, you want 3 zeros to be present. Again, for the next row, you need 2 zeros to be present. For the next one, you need 1 0, and there will be another row also, 5 rows, and there cannot be any zeros also, whatever. Okay, this all can be zeros also or 1 also, whatever. Okay, so I'm representing it by sort of tilde. And you see, what do you require for this? 4 zeros for the first row. Okay, 3 zeros. So for n equals to 5, for the first row, you need n minus 1 zeros. For the second row, you need n minus 2 zeros. For the third row, you need 2 zeros, 1 0, and maybe anything. Okay, and these all zeros should be to the extreme right only. Okay, for now, for this configuration, what can you say? Rightmost one in this whole row. So this is let's say this is a whole row, right? So this is a whole row of a matrix. So where is the rightmost one? if we find that, so rightmost one, which have the same color, rightmost one is at position 1, position 0. Okay. So for the ith I equals to 0 here, right? Again, the rightmost one is at not at position 0, but it may not be at position 0 also, less than equal to position 0. Okay. Similarly, you can say that rightmost one here is less than or equal to position 1. Here it can be a 1, or if it is a 0, then here it is a 1, or it may be a 0 here also. What we can say is that rightmost one is at position 1, less than equals to position 1. Similarly, for the ith row, we can say that rightmost one is at position I is at less than equal to position I. Okay. So I hope you do understand that an entire row can be replaced by what is the position of the rightmost one. Okay. So an entire row you can replace by what is the position of the rightmost one. Okay. So you create an array. Okay. So you create an array, let's say, and this array consists of n elements, and in this array, let's call this array pos. Okay. In this array, ith element stores uh, rightmost one at position at row I. Ith element will store rightmost one position at ith row. Okay. Let's have this. Let's have this. And if you see, if you sort this array, so what do you need? What do you need? If you sort this array, uh, you must have 0 at the first, 1 at the second, and so on, or less than that. Okay. I hope you do understand what I'm trying to say. So let's see. Let's try to do the code at first and begin with the coding at least. Then we will also understand in detail on the way. Okay. So let's have this grid.size with us, and let's have a position vector, position of n, and what we are going to have store the rightmost one, right? So for the second loop, we can have iteration starting from the right of the row. So this and j minus 1. Okay. If you see ever that grid ij is 1, what you will do, already got the rightmost one. So at position I, at the ith row, you got the position of the rightmost one to be j, and yeah, that's all. That's all. You can just break from the loop. You can just break from the loop. You already got, and you just want to go ahead with the next row, because for this row you got the answer. You got the rightmost one. Okay. So after having this, let's have an int answer, and you want to see if this is possible or not. Okay. So let's say for 5, you got this answer to be something like 2, 1, 0, 3, 4, something like this. Okay. And what do you mean by this? What do you mean by this? What do you mean by this? If you construct the matrix, the ith row, that is the first row, okay, 1, 2, 3, 4, 5. This first row at the position 2 is having a 1. The rest all are zeros. Okay. This means just this. Okay. And there can be anything. And for the second row, at position 1, there is a 1 and zeros are here. At position 0, there is a 1. At position 0, there is a 1, and the rest all are zeros. Similarly, for this, there at position 3, there is a 1, all are zeros, and for again the last one, at position 1, there is a 1. Position 4, there is a 1. Okay. And if you try to see, you can always rearrange this to have. So if you are able to bring this row to the first, okay, so if you are able to do something like this, bring this row to the first, keep this row as it is, okay, and again bring this row here. And yeah, I hope you do understand what I'm trying to say. So basically, you see the position for this was 0. The position for this was 1. The position was for this was 2. So you need to basically sort this whole array. Sort this whole array in 0, 1, 2, 3, 4. And you want to check that how many position I need to swap, not just sort. You need to check that for how many position I swap. And also you need to see that uh, does there exist number at all. So let's say you are searching a position I. So at position I, let's say I equals to 1, you are searching for a 1 or less than that, okay, right? And if you see that something like this 1 2 2 3 4 is there, then you can never get such a kind of answer. You can never get such a kind of answer. I hope you do understand what I mean to say. So yeah, that's what you need to check. And if you got such an answer, what do you need to do? You need to swap. So this 0, so if you see, you got a 0 over here, and you at I equals to, see, at position I, you want something of value I or less. Okay, so at position I equal to 0, you want to swap this element. So you swap this all the way back to this. Okay, so if you at J position, if you got this at 0, so number of swaps will be J minus I. Okay, number of swaps will be J minus I. We can add that to our answer. So I hope you do understand that this position array, we again need to have a different loop, okay, and for int j equals to I, we will start with I, j less than n. I hope you do understand. I'm not getting any confused where we are starting with I, because at the jth position we have already uh, sorted the first few elements. Okay, so what we are doing is that at the first I, we are seeing that, hey, where can I get a value of less than equal to 0 in the future? Okay, and at position 1, you are saying that, hey, where can I get a value of uh, less than equals to 1? You see that you got a value at j. You want to bring j all the back to here. Okay, and you want to swap these elements. After swapping, I hope you do understand what will that become. It will be 0 2 1 3 4. Okay, 0 will be at the first, and 2 and 1 will be shifting 1 places to the right. So you need to simulate this whole thing. So yeah, at every position, what do you need? So if at position of I, okay, for the ith row, whatever position is there, is that should be less than or equals to position of j. Okay, so you go to the jth place and see whatever value is there, that should be less than or equals to I. Yeah, I hope you do understand, because at position I equals to 1, you are searching for an element which is less than or equals to 1. Okay, at position I equals to 2, you are searching for an element which is less than or equals to 2. So yeah, at position I, you want to search for an element which is less than or equals to I. Okay, so yeah, if this is true, you have got something to swap. Okay, and what you need to swap is essentially j minus I. Okay, and you can have a k value, k, which is initialized to -1 at first, and here k will be equals to j, and you remember to break from the loop because you already got that position. And if you see something like k is -1 still, you can simply return -1, because what does that mean? That simply means that for ith position, you went on to search the whole array for a position j which is less than or equal to I, but you did not find anything. You did not find it. If you would have found, your k would have been modified. So if k is not modified, k is still -1, it means that for position I, you did not find any element which is less than or equals to I. Okay, else what you need to do, you shift all the elements. Okay, so 0 you shift at first, but all the next elements you shift to the right. Okay, so what you need to do for, let's say, an int x, uh, you want to start from k, okay, and x greater than j, uh, not j, I, x minus minus. Okay, I hope you do understand what I'm trying to do. And I'm trying to swap this position of x with position of x minus 1. So I went to the index till j. See, k is nothing but j. I stored here, right? And I saved the value of j in k. So from j to I, essentially, I am iterating backward and shifting all the position and swapping all of these numbers. Okay, so I'm swapping this 1 with 0. I'm swapping this 2 with 0 again to get this 0 1 2. Okay, to get this 0 1 2 and 3 4 is as it is. I hope you do realize what I'm doing. And yeah, that will be all, I guess. That will be simply all. And if you try to just return for the answer, I hope this will work just fine. Let's see if any kind of debugging or anything we need to do. I hope at least the approach is very clear to you and not at all confused. You see, we get an accepted if you try to submit it for all cases. I hope it will just work smooth and no problem with that. So yeah, it is taking a bit of time for execution. I don't know why. Let's wait. So you see, we got the accepted thing. We have a very decent runtime complexity as well as memory. And I hope in this n equals to 200, we solved it in essentially O of n square time complexity, and our space complexity is O of n. You can also say your space complexity of O of n square because the grid itself is an n square value, okay, which you need to store anyways. But the extra space which you are using is nothing but O of n. So yeah, that is all for this problem. And I hope there was no confusion. If there's any doubt, you can definitely ask me in the comment section. Yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.